Good afternoon, it's Tuğba Ersoy, and today in this presentation I would like to briefly summarize my term paper subject, which is aromatic amino acid decarboxylase or AADC deficiency. I will start with introducing the disease and its molecular mechanism. Then I will continue with signs and symptoms, diagnosis, and finally I will end up my presentation with treatment possibilities. AADC deficiency disease is a very rare disease caused by the decreased activity of aromatic amino acid decarboxylase enzyme due to the mutations in the genes coding this enzyme. The genes that codes for the enzyme is called DDC gene, or in other words, dopa decarboxylase gene. The disease affects babies who seem healthy at birth and starts developing the symptoms starting from the first months of the life. They have relatively short lifespan compared to the healthy individuals, as they have increased likelihood to have medical complications. The disease is autosomal recessive disease, which means in order to have this disease, individual must inherit the 2 copies of mutated genes separately from each of the parents. AADC enzyme, which is deficient in this disease, functions in neurotransmitter production. Neurotransmitter is highly essential as it enables communications of neurons, therefore leading to the proper functioning and signaling of the body. In normal cases, neurotransmitters are produced in adequate level, but when the enzyme is deficient, the neurotransmitter levels should be the neurotransmitter level drops significantly. The neurotransmitter involved in AADC deficiency can be listed as dopamine, serotonin, epinephrine, and norepinephrine. Dopamine normally functions in movement control, while serotonin plays a role in sleeping, memory, appetite, and mood functioning or control. On the other side, epinephrine and norepinephrine regulates autonomic nervous system, which control the internal organs, as you can see in the figure. So when we come into the signs and symptoms part, most frequently movement disorders can be seen, which includes low muscle tone, which makes the babies look floppy, as in this picture, abnormal rotation of eyeballs with gaze looking upwards, increased muscle tone of the limbs, uncontrolled movements of head and neck, and occasionally chimerism is repeating and lasts for an hours in between 2 to 5 days. Other than movement disorder, autonomic nervous system disorders can be followed. That consists of excessive salivation and sweating, unstable body temperature, low blood pressure, hypoglycemia, which can be described as low blood sugar, and the affected individual might have gastrointestinal problems such as reflux, diarrhea, and constipations. This individual might have developmental delay as they cannot achieve the milestones of life such as walking or talking. And I mentioned at the very beginning of my presentation, this individual has relatively low lifespan due to the increased likelihood of medical complications. In order, after some physical examination by physicist, And after detecting the signs and symptoms that are listed on the previous slides, then the diseases can be diagnosed through blood tests that measures the activity of AADC enzyme, and it is expected to be lower than the normal levels in the affected individuals. After that, lumbar puncture can be applied, which is simply placing the needle into the spinal cord of the baby to collect the cerebrospinal fluid in order to detect the neurotransmitter levels. And as I mentioned earlier, the neurotransmitter levels should be low in the patients. Also, genetic testing can be used for the detection of the mutated genes through the whole genome sequencing or next generation sequencing methods. And currently, studies have found that specific metabolite called GOMD is elevated in these patients on the dried blood spot assay. And this diagnosis method can be applied to the newborn screening for the early diagnosis. So when we come into the treatment possibilities, unfortunately, there is no cure for the disease, but the controlling of the symptoms can be possible. As the severity of the disease's progression varies in between the individual, personalized treatment should be applied. So dopamine agonists such as ropinirole or rotigotine can be used as treatments as they increase the levels of dopamine, which is already in a low level in the patients. On the other side, monoamine oxidase inhibitors such as selegiline and phenelzine can be used. Monoamine oxidase is actually the enzyme that degrades the neurotransmitters that are already in a low level in the affected individuals. So we don't want to the functioning of the enzyme, and so we want to stop it through some medical drugs. Pyridoxine and vitamin B6 supply can be used as treatment as they are the cofactor of the enzyme, so it increases the functioning of the enzyme even though it's a highly low levels in the blood. In addition, the treatments listed in the previous slide, melatonin supplies can be used to overcome the sleeping problem, as the serotonin is one of the affected neurotransmitter from the diseases, and melatonin is produced by the serotonin. So when the serotonin levels are low, melatonin levels are also expected to be low. That can create some sleeping problem, but we can give it to patients externally and solving this sleeping problem. Anticholinergic drug as well as benzodiazepines for movement disorders can be used as they are balancing both dopaminergic and cholinergic pathways. And one recently discovered treatment is gene therapy, which aims replacing the mutated DDC gene with functional one. And I would like to give a bit detail on this gene therapy treatments. So as it aims to displace the mutated gene with the functional one. A viral vector is injected to the specific brain region called putamen. The viral vector that is injected contains cDNA, which encodes the non-mutated version of dopa decarboxylase DDC gene, which at the end produces AADC enzyme. And when the dopa decarboxylase gene is fixed with the functional one, it restores, it ends up being restored, restoring the AADC enzymatic function. And as I told you at the very beginning, AADC originally converts the L-DOPA molecule into dopamine neurotransmitter or some additional neurotransmitters, as you can see in this picture. So this brings me to the end of my presentation. Thank you for your kind attention. And for those of you who are interested in, here is my reference list.